Yes, screen is visible. Screen is visible, please.
Yes, sir.
Anyone? Screen is visible.
Yes, sir.
Okay. Up to last lecture, what we have discussed, can anyone revise? Anyone? Anyone revise, please? Online students, please. Can you revise what we have discussed up to now? What we have discussed? Raut Anmol. Anmol Raut. Are you there?
Yes, sir.
What we have discussed up in previous lecture, can you revise?
Application of power electronics.
Okay.
Block diagram of power electronics.
Okay. What are the components of power electronics? What are the components of power electronics?
Diode rectifier, DC to AC converter, DC to AC, AC to DC converter, DC to DC.
These are the types of converters. Whatever you are saying, that is correct, but that is types of converters. Okay, I am asking what are the components of power electronic system? Have you seen the block diagram?
Yes, sir.
ब्लॉक डायग्राम में क्या क्या लिखा है? ब्लॉक डायग्राम में क्या क्या लिखा है?
Source of electric power.
Okay, next.
Power converter.
Okay.
Load.
Okay.
And controller.
Okay. Yes. Clear? These are the components of power electronic system. Very good answer. Clear? Okay, so don't tell if anyone asking the power electronic converters components. So don't tell the types of converters. Okay, types is different and components is different. So today we are going to discuss classification of switches based on the flow of current and blocking capability of the switches. Okay. On the basis of blocking, the switches are classified into two types, unipolar and bipolar. Clear? Just wait, just 1 minute. Okay, based on the blocking capability. So the switches have been classified into two types, unipolar switch and bipolar switch. Clear? So what is meant by unipolar switch and what is meant by bipolar switch? Can anybody tell? Already you know the basics of the switches. Anyone please? What is unipolar? What is bipolar? Anyone please? Okay, based on the blocking. For example, For example, if one switch is there, is it right? Uh, just wait. For example, if we take the diode, what is the symbol of this? What is the symbol of this one? Diode. So this is the anode and this is the cathode terminal. Is it right? So if we are applying the voltage, okay, and this one is the positive, this one is the negative. This one is the positive and this one is the negative. So when the anode is made positive, so the current is flowing through the switch. Is it right? The switch will be turned on. The switch will be turned on and the current is flowing through the switch. It is clear? So it is not having any blocking capability during this condition. Okay, it is not having any blocking capability during this condition. Is it right? And second case, same thing. In second case, same circuit and same symbol. We are taking the diode. Okay, and the same we are giving the supply. Same we are giving the supply. Single phase AC, but polarity is reversed. This one the negative and this one the positive. Are you got the difference? In previous case and next this case. Now the cathode is made positive. Cathode positive and Abhi. Cathode is connected to the positive side. Is it right? And anode is connected to what? Anode is connected to negative. So can this diode is turn on? Will it turn on? Can this diode is turn on, please? Anyone? Can the diode is turn on? If cathode is made positive and anode is negative, is there any chance to turn on the diode? Online, no one is giving the response. If cathode is made positive and anode is negative, whether this device is turn on or not, please tell me. Preeti, Bagal Preeti, Prajakta, no one is giving the answer. Okay, so the diode is not. Yes, very good. Okay, the diode will not be turned on, means it will block the voltage. Is it clear? So when the cathode is made positive and anode is negative, it will block the voltage. Clear? So it is a unipolar device or bipolar device. Bipolar device किसको बोलते हैं? अगर both cases it will block the voltage, so then it is called as a bipolar device. Okay, if only in one side it is blocking the voltage, okay, but it will not have the capability to block the voltage when the anode is made positive. Directly it will turn on. So it is not having any capability to block the voltage when the anode is made positive. So that's why what we can say, the diode is considered as a unipolar switch based on the blocking capability. This point is clear, all of you? This point is clear? This point is clear, please. All of you? Okay, so bipolar किसको बोलते हैं अपन? For example, we are having the thyristor. We are having the thyristor. Okay, this is the thyristor. Okay. What is this? Source. Clear? This is the thyristor we have taken. In previous case, we have taken the diode, and in this case, we have taken the thyristor. So, when the thyristor is having the three terminals, anode, cathode, and this is the gate. Three terminals. In the case of diode, only two terminals. Okay. So, if supply voltage is like this, positive and negative, if anode is made positive, and cathode is negative, okay, so the thyristor is turn on or turn off? The thyristor will not be turned on, because thyristor will be turned on when the some amount of voltage is applied to the gate circuit. Then only it can turn on. Otherwise, it will not be turned on. Clear? So it will be, when the anode is made positive and the thyristor will not be turned on, so it will have the capability to block the voltage. Turn on नहीं हुआ तो क्या हो जाएगा? Current flow होता है क्या? Turn off मतलब blocking है ना? So when the anode is made positive with respect to cathode, when the gate is zero, so it will block the voltage. Clear? And second case, in second case, just reverse, take it. This one the negative, and this one the positive. So here cathode is connected to what? Positive, and anode is connected to what? Negative. So whether it can turn on, there is no chance to turn on the thyristor. Clear? So because the cathode is made positive, so if the cathode is made positive, obviously the device, there is no chance to turn on the device. So means this thyristor device can have the capability to block the voltage in both directions, in both polarities. Okay, so that's why this thyristor can be called as a bipolar device. But in the case of diode, unipolar device. Are you aware the difference between the unipolar and bipolar devices? Clear? Okay, so unipolar, those switch which can block only one polarity of the voltage. So for example, diode, okay, it will conduct only when VA greater than the VK, means anode voltage is greater than the cathode voltage, then only it can conduct. Okay, so when VA is greater than VK, so current is flowing through the device, zero नहीं होता है, so obviously I is not equal to zero. So, but when the VA less than VK, when the cathode voltage is greater than the anode voltage, so the diode will not be turned on. So it will block the voltage. Okay, so then that time current is zero. Okay, and voltage is not equal to zero. Maximum voltage block karta hai. Clear? So that's why the diode best example is for unipolar device diode. So the diode is a unipolar device. But in the case of bipolar device means thyristor. It can block the voltage from anode to cathode as well as cathode to anode in both direction. Clear? So that's why for bipolar switch we are considering the thyristor. Okay. Next, based on the flow of current. पहले कौन सा था? Based on the blocking capability of voltage. Now based on the flow of current. So how many in how many ways we can classify the switches? Two types, unidirectional and bidirectional. पहले previous case unipolar and bipolar, but in the case of flow of current, based on the flow of current, unidirectional and bidirectional. Is it clear? So if the current is flowing from anode to cathode, if the current is flowing okay, if the anode is positive and cathode is negative, so the diode is turn on or turn off? The diode is turn on, so the current is flowing. Is it clear? Next, same case, if cathode is positive, if cathode positive, anode is negative, then what will happening? Whether the current is flowing, okay, there is no chance to flow the current in reverse direction. Okay, so I is equal to 0. I is equal to 0. So the current cannot flow from anode to cathode, cathode to anode. So only this device can be considered as unidirectional or bidirectional. Only unidirectional, because only the current will flow from anode to cathode. So there is no chance to flow the current from cathode to anode. If in case any current is flowing from cathode to anode, so definitely the device is going to get damaged. It will not happen like that. Okay, in case by mistake, if any current is flowing from cathode to anode, okay, so the diode is going to be damaged. Clear? Next, bidirectional switch किसको बोलते हैं अपन? Which device can be called as a bidirectional? For example, if you are taking the thyristor, or SCR, so what will happening here if your anode is made positive and cathode is negative? Okay, if the gate is some voltage is applied, so there is a chance to flow the current from anode to cathode. If the device is turned on, the current is flows from anode to cathode. Okay, if cathode is made positive and anode is negative, so there is no chance to flow the current from cathode to anode. So this thyristor is also unidirectional device. Are you getting? But in the case of voltage blocking capability, that is the bipolar. But in the case of flow of current base paper, ये bidirectional device. ये भी unidirectional. Clear? Yes. Next one. So which one is the bidirectional device? Which one is the bidirectional? For example, if we are having the diac, okay, this is the diac. These two diodes are connected in anti-parallel. Anti-parallel connect है क्या? So two diodes are connected in anti-parallel, then it will become a diag. Okay, so if this is, for example, this is the terminal one. For example, this is the terminal one, and this is the terminal two. So here we cannot say anode and cathode. Okay. So for example, this is the terminal one and terminal two, and this is, if terminal one is made positive and terminal two is negative, then what will happen? The current is flowing through the in this direction. Clear? Next case. If terminal 2 is made positive and terminal 1 is negative, what will happening? Still the current is flowing in this direction. Clear? Because this is the bidirectional device. ये डिवाइस टर्न ऑन होगा अभी, ये डिवाइस टर्न ऑन होता है, प्रीवियस केस में ये डिवाइस टर्न ऑन होता है. So means there is a chance to flow the current from terminal 2 to terminal 1 and terminal 2 1 to terminal 2. So this is a bidirectional device or unidirectional device? This is a bidirectional device. Is it clear? The concept is clear, all of you? Concept is clear? Anyone? At least put the message in chat box. What I have to understand. Bidirectional device, another device. Track with bidirectional device. This is just I am this switch. This is also bidirectional. The switching. उल्टा करंट के तो bidirectional flow होता है. Yes, please. Next one. Okay, before going to construction of the thyristors, so I would like to say the some devices, symbols of devices. Just wait. Screen is visible. Screen is visible, please. Okay, so check the some power semiconductor devices. Its names and symbols. Okay, is it clear? So all of you, you have to note it. So what is the name of the symbol? What is the name of the symbol? No response. Students online, what is the name of this symbol? Pratiksha? Kade Pratiksha? More Rani, I will put absent. Please remember. If you are not giving the answer when I am calling with mention name, So Kade Pratiksha and Rani Moore is absent for today lecture. Okay, so this is the symbol of the diode and it is having two terminals. It is having two terminals. What are those? Anode and cathode. Clear? So the voltage rating of the diode is 5000 volts and the current ratings of the diode is 5000 amperes. Okay, and the frequency range is 1.0 kilohertz. These are the rating values of the diodes. Now somewhat little bit is increased. Okay, अभी day to day क्या हो जाएगा voltage ratings बढ़ गया. Okay, so next device is the thyristors. Next device is what is it one? Silicon control rectifier. These are the thyristor family. Okay, this one, this one, this one, this one, this one, thyristor family. Okay, SCR is also one type of device or one type of family member in thyristor. SCR means silicon controlled rectifier. Okay, I will explain what is SCR, how it works. Okay, just before going to introduce the SCR, so we have to know what are the devices are there of the power semiconductor devices. For that purpose, we are going to discuss. This is the SCR and it is having three terminals: anode, cathode, and gate. Okay, this is the symbol of the SCR. Okay, anode, cathode, and gate means how many terminals are there for SCR? Three terminals. Clear? And what are the what is the voltage rating of the SCR and what is the current rating of the SCR? 7000 volts maximum voltage rating of the SCR and 5000 amperes and 1.0 kilohertz frequency range. Okay. Next device, laser. What is the full form of laser? What is the full form of laser? Light activated silicon controlled rectifier. Clear? So how many terminals are there for this device? It is also having three terminals. It is also having three terminals. What are those? Anode, cathode, and gate. Okay, it is also having same terminals, but only symbol is different. Symbol यहाँ पे क्या होगा? दो arrow mark आ गया. Clear? So that will indicate the light. With the help of light, it will turn on. Okay, by doing the heat. Okay, like that. Okay, it is having three terminals, anode, cathode, and gate, but the symbol is different. So you can observe it one. This is the symbol of laser. And this is the voltage rating of the laser. And this is the current rating of the laser. And this is the frequency range of the laser. 6000 volt and 3000 amperes and 1.0 kilohertz frequency ranges. Next. What is the next device name? ASCR or RCT. Asymmetrical silicon control rectifier, or RCT means reverse conducting thyristor. Reverse conducting thyristor, because it can conduct in reverse also. So why it will conduct the reverse also? Because we have taken the thyristor and we have taken the one diode. This diode is connected anti-parallel. So when this become a positive and this become a negative, the current is flowing through this direction. Na? Is it clear? That's why this device can be conduct in reverse also. So that's why they have given name for this is reverse conduct thyristors. Is it clear? So how many terminals are there for this device? Same three terminals, but symbol is different. What are the names of the terminals? Anode, cathode, and gate. Clear? And this is the symbol. And what is the voltage rating of the RCT? 2500 volts and 400 amperes and 2.0 kilohertz. Maximum frequency range is 2.0 kilohertz. Next, GTO. What is the name of this GTO? Gate turn off devices. sorry, gate turn off thyristor. Okay, gate turn off thyristor. That is simply in shortcut we are calling as a GTO. Clear? So it is also having three terminals. What are those? Anode, cathode, and gate. So difference is what? SCR को और GTO की क्या difference है? SCR is like this. SCR is look like this. Clear? But G2A is this is the anode and this is the cathode. And what is this? Gate. So इसका difference क्या है? But in the case of gate circuit, the current can flow in both directions through the gate circuit. But in the case of in a SCR, only in one direction the current can flow through the gate circuit. That is a small difference is there. That's why we are represented like this, like this, like this. Current can flow in both directions. That's why they have represented like this. यहाँ पे दिख रहा है क्या? Symbol. A small difference is there. So please remember. Yes, tomorrow I will ask to all the students, draw the symbol of SCR, draw the symbol of triac, draw the symbol of diac, draw the symbol of GTO. Clear? Next, SATS. Next device is static induction thyristor. Clear? Next device is static induction thyristor. So what are the terminals of this static induction thyristor? Same as thyristor. Terminals of the static induction thyristor is anode, cathode, and gate. But difference is what? Difference क्या है? Difference क्या है? Thyristor और SATS का. Gate terminal इधर connected है. That is a small difference. Clear? Construction is somewhat different. Clear? If the gate terminal is connected like this at this place, so it will called as a static induction thyristor. Okay. And the voltage rating of this SATS is 2500 volts and current rating is 500 amperes. And the frequency range is 100 kilohertz. Clear? Next one. Next one is what is the next one? What is the next one? MCT.
MCT.
Yes. Full form of MCT is mass controlled thyristor. Clear? Mass controlled thyristors. So what is the symbol of this device? This one. It is also having three terminals, gate, anode, and cathode. But the construction is looking like a transistor. The construction is looking like a transistor. Construction is looking like a transistor, but terminals is thyristor, anode, cathode, and gate. But it will consider in the thyristor family. Clear? It is also one of the member in the thyristor. Next one, the triac. Triac. This is the triac. Same as it is. Diac symbol देखा अपन. Diac symbol देखा previous. Okay, so same as it is, but only one gate terminal is provided. The gate terminal is provided. So this gate terminal is common for both the devices. This gate terminal is common for the both devices. That is called as a triac. So the terminals of the triac is MT2, main terminal 2, and main terminal 1, and gate. What are the terminals of the triac? Main terminal 1 and main terminal 2 and gate. Clear? Next, what are the voltage and current ratings? 1200 volts of the voltage rating, 1000 amperes is the current rating. Clear? And 0.50 kilohertz is the frequency range. Means frequency range कम है इसका. Yes. Next, means इसको क्या बोलते हैं अपन? लो वोल्टेज हाई करंट डिवाइस बोल सकते हैं ट्रायक. लो वोल्टेज एंड हाई करंट डिवाइस बोल सकते हैं ना? Is it clear? Because the voltage rating is small, but current rating is very high. So that's why this triac can be called as a low voltage and high current devices. Or we can also call as low frequency device. Next one, transistor family. BJT, BJT full form क्या है? Bipolar junction transistor. यही है ना? I think you have studied in EDC. Okay, so what are the terminals of the BJT? Base, emitter and collector. Clear? Base, emitter and collector. Clear? And this is the PNP transistor, this is the NPN transistor. If the current is flowing inside, it is called as PNP. If the current is flowing outside like this. Clear? That is the NPN transistor. Okay, you are observing this direction यहाँ पे. Okay, if the current is flowing from collector to emitter, that is called as NPR. If the current is flowing from emitter to collector, that is called as the PNP transistor. Okay, so the voltage and current ratings of the transistor is 400 volts, sorry, 1400 volts and 400 amperes. And the frequency range is 10 kilohertz. Next one is the MOSFET. MOSFET, what is the full form of MOSFET? Metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor. Is it clear? So this is the symbol of the MOSFET. It is having three terminals. What are those? Gate, drain and source. What are the terminals of the MOSFET? Gate, drain, source. In the case of BJT, base, emitter, collector. Base, emitter, collector. But in the case of MOSFET, gate, drain, source. Clear? Next, voltage and current ratings is 1000 volts, 50 amperes, and the frequency is the 100 kilohertz. Frequency range बहुत है ना, 100 kilohertz है. So इसको बोल सकते हैं अपना high frequency device. So this MOSFET can be called as a high frequency device. So sometimes in oral examination can ask the question, what are the high frequency devices? Can you tell any one name? Simply you have to tell MOSFET is the high frequency device. Clear? Okay, next one. SAT. Static induction transistor here. वहाँ पे SATS means static induction thyristor. Here SAT means static induction transistor. Okay. So symbol is looking like this. It is having three terminals: gate, drain, source. But some symbol is different. Symbol थोड़ा सा different इसका. So terminal same. Gate, drain, source. MOSFET का terminals gate, drain, source. SAT का terminals gate, drain, source. But symbol is different. Is it clear? So its voltage rating is 1200 volts and current rating is 300 amperes and frequency range is 100 kilohertz. It is also high frequency device. Clear? Next, IGBT. Next one, the IGBT. What is the full form of IGBT? What is the full form of IGBT? Insulated gate bipolar transistor. insulated gate bipolar transistor. Is it clear? So what are the terminals of the IGBT? Gate, collector and emitter. Gate, emitter and collector. Are you getting the difference? BJT का terminals base, emitter, collector. MOSFET का terminals gate, drain, source. IGBT का terminals gate, collector and emitter. This is the combination of the MOSFET and BJT. IGBT is the combination of the MOSFET and BJT. Is it clear? कलेक्टर टर्मिनल्स किसमें? बीजेटी में. एमिटर टर्मिनल किसमें? बीजेटी में ना. बीजेटी में कलेक्टर और एमिटर प्रेजेंट है और गेट किसमें प्रेजेंट है? मॉसफेट में. सो द कॉम्बिनेशन ऑफ द मॉसफेट एंड आईजीबीटी कैन बी कॉल्ड एज आईजीबीटी. इज इट क्लियर? So voltage rating is 1200 volts, 500 amperes current rating and 50 kilohertz. So 50 kilohertz is also high frequency. So it is also can be considered as a high frequency device. Clear? So these are the some number of devices are there, but main important devices I have shown here. Okay, these are the some important power semiconductor devices. Diode. Okay. And next one. Diode is the uncontrolled device. Diode is uncontrolled device. Clear? And thyristor is a semi-controlled device. Thyristor is a semi-controlled device. Transistor is a fully controlled device. Based on the controlling, the switches have been classified into three types: uncontrolled, semi-controlled, and fully controlled. Uncontrolled means diode. Diode is not a controlling device. So that's why the diode can be considered as a uncontrolled device. And semi-controlled is the thyristor. This is clear? And fully controlled is the transistors. Okay. So these are the some basic devices, symbols and ratings of the power semiconductor devices. Is there any doubt? Is there any doubt? Please. Online students. Any doubt, please? Give the reply. No. Okay. Just wait, I will take attendance.